Hi, I'm Bob Alsop with ShopSabre CNC. Around here they call me Router Bob. Today's video is going to be polycarbonate cutting, and it's a part that goes in a private jet, and the edges have to be really good. So it's going to be a great demonstration. Polycarbonate is a really unique product. It looks like plexiglass, but it's much more durable. In fact, if it's thick enough, it's bulletproof glass. Now, it's used in applications for durability. In our case, we're actually going to be making a shelf that goes into a private jet. It's 1/2 inch thick. It's really going to look like a glass shelf, and there's some different machining in it. Now, if we're doing things out of acrylic, we can flame it and treat the edges, but that's not the case with polycarbonate. So what we machine is really critical. And it just so happens our friends over at Vortex just created some tools just for doing this. So we're going to be using those. But first, let's take a look at what the part actually looks like. Here's our part, and to give you an idea of what it is, it's 1/2 inch thick polycarbonate. It's roughly 24 by 12. It's a little smaller than that. It's a part for a private jet. And I think it's probably something that's on the shelf, and I believe these little cutouts here are to keep something from moving around. Now, here's what's unique about this. You can see the edges on it, and you're going to pretty much be able to see all the edges. So what's so difficult about making this part are the edge finishes, because you see them. Whereas if you're doing something like acrylic, you can flame it. You can't really flame this, so we have to produce perfect edges here. So it's a really nice project. Now, I added some holes here. They weren't in the original drawing, but the reason I added them, I wanted to be able to show you how to use one of those bits as a drill. But that's our part. Now let's talk about how we set this up on the machine. You could actually use flow through for this, but we do a lot of stuff with flow through, and if you don't really understand how to gasket stuff, you're missing out on a lot of capabilities. So I thought, well, we'll gasket this, and I'll show you how easy it is because I have part locator pins and a vacuum table. So let's hide this. Now, this piece right here is what I call a fixture board, and it's 2 feet by 4 feet, so it's big enough to cover the front vacuum zone. I position it with a part locator pin, so it makes it really simple. Now, to create a vacuum gasket, first off, what I'm doing is this cut right here basically shows me where the blank goes. That's how I get it lined up. All right, and then this is actually gasketing. And it's a foam gasket. It's a 1/4 by 1/4. It fits down into a slot that's 3/16 deep. And then this is actually just a vacuum groove, and it's a 1/4 inch deep, and that's to circulate it. And then the last thing we have to do is actually access vacuum from underneath. So I've got a couple of holes here. Now, one of the things I do when I drill those holes, I don't drill them all the way through in case I miss. All right, so I actually machine those when I machine them about 3/8 deep, and that way then I can drill those all the way through with the drill and not take a chance at damaging the table. And it's real easy to figure out. You know, once you've got this done, all I have to do is measure from here to where one of the grooves is, and that's where I put the hole, and it has to line up. So it's really simple. So basically, that's how the setup's going to be on this. And then what happens is we put our blank on there, once again, and then we run the Toolpath. Now, there's a couple things about this setup we need to talk about. Number one is make your blank slightly larger than the finished part, because you don't want a bunch of pieces laying on the table loose unless they're gasketed in place and held in place. So just plan on making it just slightly large enough. Now, we're going to have an area here that we will have that's a cutout. In fact, let me hide this and you can see it. There's actually an area that's cut out here. There's no vacuum underneath there, so we're going to have to treat that separately, or it's going to become a projectile. So it's a really good project. Now let's look at how we set this whole project up in VCarve Pro. Now here's VCarve Pro, and let me show you how I set this up. First off, let's go over here to material. And basically the material is 48 by 24. The thickness of the material is 0.49, and we're touching off to the top of the spool board. The lower left-hand corner is the origin. So there's nothing exotic about that. So that's how that's positioned. Now, you'll notice there's really two drawings here. There's one drawing that has to do with tool pathing the part, then there's another drawing related to the fixture. So if I double click this, there's with VCarve 11, there's actually the ability to have more than one sheets, and they can be separate parts. So this is what I'm actually using to create the fixture board, and this one I'm actually using to create the part. So let's talk about the part first and how we actually do that. All right, now let's talk about how we tool path. And the first thing we're going to do is let's deal with these holes. Now those weren't in the original drawing. I put them in there because I wanted to show you something. Our friends over at Vortex sent some tools over for us to test just for this, and they're actually the 5600 XP, and they're great. They're single flute tools. It turns out you can drill with them because they cut on the end. So I actually used a 1/4 inch one and treated it just like a drill. And the only, oh, by the way, is they leave this huge chip which wraps around your spindle, so you have to peck drill them so it breaks those chips. So here's how I did that. Let's go to Toolpaths. Go over here to drill, block that. We'll go here to drill, open that up. So there's a 1/4 inch single flute, that's my tool, cutting all the way through plus a little bit. And this is where you do the peck drilling, and this peck depth is determined here where it says pass depth. That's where that gets determined. All right, and basically what that's going to do is it's going to make that hesitate, and it'll break that chip. So instead of this great big long chip, we're going to end up getting these little segments, which is exactly what we want. So that's how we did that. Okay, so that's the first thing we do. Now, there's another, oh, by the way here, and that is this area right here. If you recall when we looked at the 3D, I've got to get rid of this material. And I can't really, you got to be careful. There's nothing holding it. I've either got to put a configuration to hold it with vacuum or really be careful how I do it. And so here's what I did. I call it a projectile because that's exactly what it'll do. If it gets loose, it becomes a bullet. So what I wanted to actually do is just do a pocket. I don't need to go around the perimeter at the end, and I just want to start from the front and move back, and then do it 3 passes. That should give us plenty of cutting action. Now let's look at that in the simulation. I'll show you what it does. We'll turn that off. Let's click that. Now when I simulate it, watch what happens. Slow that down a little bit. I'll slow that down where you can see it. And now let's try it. Now you see how it starts at the outside and it works its way in. So we're cutting from the outside in. So it never leaves any material. So there's the first pass. Okay, there's the second pass. I could probably have done this in 2 passes instead of 3, but I didn't want to take a chance of something coming loose. Once again, and when you start with your blank, make your blank as small as you can get by with. Leave yourself an 1/8 or 1/4 inch because we don't want to leave scrap pieces laying out there because bad things happen. For one thing, if a piece gets moved, it may show up on your edge. Remember, we're trying to produce perfect edges here. And then this last cut actually does the final. So when this is done, we're done with that scrap area. So that's just, sometimes you have to figure out how do I handle that? You know, what approach do I use in that situation? So that worked out pretty good. All right, that's pretty good. So now we've got our holes drilled. We've got the projectile eliminated. Okay, we'll close that. Now, the next thing since I've got the 3/8 tool in there, it's a 3/8 single flute, I'm going to use that also for these. So I call those pockets. So there they are. And we did that in a single pass. And if we look at the simulation, do this. They'll just get cut out. They're just a simple pocket. We can speed this up a little bit, I think. There we go. Once again, all this is done with the same tool with the exception of I drilled the holes with a 1/4 inch bit. I'm not sure what goes in these, but something sits on this shelf, and those pockets are to keep it from moving around. It might be glasses. It could be a beer can. I don't think they're big enough for wine bottles. So now, so far, we've drilled our holes, we've got rid of the projectile, and we've cut this. So what we have left is really the outside, and we need to talk a little bit about how that gets toolpathed. All right, let's take a look at that. We'll close that. Now, the way we do the outside, first off, let's talk about lead-ins and lead-outs, because if you do a lead-in in polycarbonate, you can always tell. If you do it on an edge, you can always tell. And even if it hesitates, you can tell. So what we typically do, we have a little bit of limitation on cutting this. And I have to stay within a certain RPM range or I melt it. Actually, if you feed too slow, it'll melt, or if you feed too fast, it'll melt. So I'm going to do a rough pass first. So let's take a look at what that is. So we'll open that up. Okay, now I'm cutting through because it's 0.49. I'm using a 3/8 tool. Now I'm doing 2 passes, all right? And so that's determined here. I basically set 2 passes. All right, I'm cutting outside the line. It's going to be a conventional cut. Now, I'll tell you a little secret. One of the things you can figure out is, you get a new tool, do you climb cut or conventional cut? A real easy way to figure that out is go out on the machine, make a cut, just a straight cut, and look at both sides. One edge of that curve is a climb cut, one edge is a finish cut. So that's how you can tell. I couldn't tell that much difference between a climb and conventional. I normally like to use conventional because it gets rid of a lot of chips. Remember, our first goal here is to get rid of all this excess material. And so I usually do that as conventional cut. Now, I'm leaving an allowance. Allowance means I'm leaving material to cut off in a finished pass, and that allowance is going to be 15 thousandths. Now, let's take a look at some tool paths. Let's go over here. Okay, we're actually going to cut. Here's what we want to control. I want to turn the spindle at 14,000 RPMs. It's a single flute tool. I want about a 9 thousandths chip load. That's pretty much where I want to be at. Where did that come from? That came from the list from Vortex. There's always a range, and I thought, well, okay, I'm going to try to create a chip thickness of 9 thousandths. All right, and so 125 inches a minute gave me that. All right, we're setting a 1/4 inch per pass. All right, so that's what's going to happen now. So that's where I got my feed rate. And once again, our idea is to go around that. We're going to do it in 2 passes, and we're going to get rid of all that material. So when we get finished with that, then we have an actual part here, and all I have to do is apply the finished pass. All right, now, so we actually have to be around that 14,000 RPM and that actual chip load to make that work really well. Then the other question becomes, well, how much do you leave for the allowance? Okay, figure on whatever, it has to be greater than your chip load, so it's got to be bigger than 9. So I just said 15 thousandths. That's a little more than 1.5 times the chip load. If you stay with those numbers, what you're doing is you're defining what you're taking off in the next pass. Okay, we have one more tool path, and this is the most important tool path because this creates what you see. So this is what determines that edge finish. Now, remember, already we've allowed 15 thousandths, so everything is real consistent. Now let's look at our tool path. Okay, let's go to finish. All right, so we're going to cut through 0.5, which is a little thicker than the material, so it should cut through. I'm going to do a single pass. Once again, I don't want to see any line in there. It's going to be an outside cut. Now the allowance is 0 because I want to cut it to the actual size, so that's going to remove the 15 thousandths that I left earlier. Okay, let's take a look at our feeds and speeds. Now, if you remember, one of the things we've always stuck with is 9 thousandths. But now what happens is the RPMs determine how fast the tool is actually going through the material. That's actually surface feed's what that's called. And we don't normally worry about that in wood, but in plastic, it makes a difference. It seems we don't have to worry about melting, so I can go really fast. So I found the best edge was if I ran at 24,000 RPMs with a chip thickness of 9 thousandths, and to create that 215 inches a minute created that. So that's the toolpath I used. All right, so that's how I made that determination. Okay, now let's actually I'll close this. Let me show you something. Okay, there's the lead in. Okay, so what I ended up doing is I came in with a lead in with a radius. So what it leads in here, it goes all the way around and it comes back out. It's a climb cut, so I'll get the best edge. Now let's look at how I set that lead in. Okay, you go to leads here, all right? I did a circular lead in with a radius of 2 inches. I did a lead length of a 1/2 inch, that's this part. I said do a lead out with no overlap. That will create a perfect quarter for you. So that's how I did that. And then it's just a matter of running the toolpath. Now let's go back and let's go to simulation and we'll review all this. So we'll reset that. So the first thing, we'll speed that up just a little bit. So we drill it. We drill those holes. Then we got rid of our projectile by just machining that stuff away. Then we cut what I assume are beverage pockets. Creates those. Okay, then we made our rough pass. There's 2 passes, so it's going to go around twice. Now once it did that, now we've got our part. Now it's oversized, and we came back and did our finish pass. And that's how we toolpathed it. And it came out really, really nice. Now let's talk about how we actually created the fixture board. VCarve Pro recently added the ability to manage multiple sheets within the same job, and it works out really nice when you're doing fixturing. Okay, we've already done this one over here. We've already created all our tool paths for the actual part, but now let's figure out how we're going to make this. So if I go to sheets down here, you'll see there's 2 sheets. There's sheet 1, which we just did, and then there's one I call fixture board, and that's this one. Now the beauty of the sheets is I can actually copy or move geometry between the 2 sheets, so it makes it real simple. All right, so to make the fixture board, what do I have to do? Well, I've got to cut. This red line is actually going to be a groove for the gasket. The one inside of that is actually going to be a groove for vacuum to flow. Then these 2 holes connect to the underside, and that's how vacuum gets to it. And the final thing I need is I need a groove out here about 30 thousandths deep, so I know where to put the blank on the table. Right, let's look at one of these tool paths. Okay, let's take a look at the vacuum groove one, all right? So you can see where it's highlighted. Now, let's look at the depth part. All right, now remember that Z0 is the top of the fixture board, so when our cuts are down in here, the software is assuming we're going all the way through the thickness of the material, so we have to allow for that. Now, you could do it this way. When it says cut depth, I could put Z. Z is a variable for whatever you entered for thickness. In our case over here, it's 0.49, and then I'm going to say plus how deep do I want the cut, 0.25, and hit equal, and it calculates it for me. So that cut would be 0.74 deep. The only thing you got to watch is you have to come over and adjust your passes, or it'll do 2 passes. So that would fix that, all right? So that's one way of doing it. You know, there's another way also. You can use this start depth. So let's do this. Let's say the start depth is really the material thickness. So that Z equal, that puts us our 0.49, and then all we do here is put our 0.25. All right, so that gives us our cut. So that's another way to do that. And I don't believe that interferes with the passes. And then once again, we just hit calculate, and it tells us it's going through, and we hit that, and that's our groove. Okay, now, all right, let's reset that. All right, so what else do we have to do? Well, we've got to do the same thing for the gasket, and for the blank, and for the holes. Remember, we drill the holes. I didn't drill them all the way through. If I open those up, I only went 3/8 through, because here's what happens. I go over to the machine, I measure how far is it from one of the pins to one over here. What I'm measuring is the grooves, and so if I happen to miss that, I don't want to cut the table. So I'm always cautious, so when I drill those holes, I leave 1/8 of an inch, then I take this, put a piece of material in it, drill it through with a hand drill. And it lines up, and it works every time, so it's a really simple method. So now what we want to do at this point is we go over to the machine, we're going to create our spoil board, and then we're going to machine our part. Let's see how this works out. Well, our part came out great, Our edges are just absolutely perfect. And, you know, that's a testament to a machine tool grade CNC router, and that's ball screw technology. There's no defects on any edge. And the tool from Vortex really worked out well. Well, I hope you enjoyed the video. If you'd like to see more videos like this, be sure to subscribe to our YouTube channel. If you have any questions, you can contact us at ShopSabre.com. Thank you for watching.